All right, what's up, everyone? I'm Sharad. I'm doing mobile security today. I got a funny stick, so this will be a pretty fun one. Okay, so who am I? I'm Sharad. I'm a fourth year here. I'm from around DC, like Fairfax, Virginia area. Wait, yeah, okay. I work at a company called 26 Technologies. I do mobile security. So that's mainly low-level mobile. Today we talk about high-level kind of Android stuff. There I do like a lot of firmware, a lot of really like kernel level Android stuff, not so much user space stuff. So some of this stuff was actually pretty new to me. So yeah, so it's pretty cool looking into this. I was called a professional fuzz tail by CTS, and I competed in AICC and promptly lost. Okay, so intro to Android. Android's a Linux-based operating system, so Linux is like kind of use that term loosely because it's very different from like stuff like Ubuntu or whatever distros you're familiar with. Really the only commonality, like the only major commonality aside from stuff like shells, is the fact that they both use a Linux kernel. That's really the major commonality here. Okay, so we're talking about Android apps. There's so much in Android that I would love to cover, but unfortunately, in the interest of time, we got to constrain stuff. So we're talking about Android apps. Android apps typically come in a form called an APK. An APK is functionally a zip file, and it contains a bunch of key components. The actual bytecode, so as some of you may know, an Android app is programmed in Java or Kotlin or basically any kind of just-in-time language. They contain, so as a result, they end up in bytecode. There's no assembly there. Actually, I mean, there can be assembly, but that's a different use case. And there's a manifest. The manifest is the Android manifest. That contains, we'll talk about that later, and resources. So resources are going to be stuff like strings, images, whatever. You can use like tools like APK tool to actually unpack them. Yeah. Okay, so the Android manifest there's like not much here, but the Android manifest is basically describes the capabilities as well as the required permissions of an Android app. Stuff like, we'll talk about exactly what's in the Android manifest a little later, but stuff like services, I guess the permission, so stuff like, for example, if the app needs to use the camera, needs to use your location, that permission needs to end up in the Android manifest. Otherwise, if it tries to use that at runtime, it's going to get rejected because that wasn't, its need for that permission was not declared in the Android manifest. On top of that, you have stuff like services. Any services that need to be used need to be declared in the Android manifest. Stuff like activities, we'll talk about what an activity is. Yeah, that's basically what an Android manifest is. So IPC, Android runs on top of a thing called Binder. Binder is pretty much the thing that binds Android together, one could say. So it's basically an IPC system. It's similar to stuff like familiar with like sysv message queues. Very similar to that. Pipes from pipes in like standard Linux, very similar to that. Basically allows two processes to communicate. In Android, processes are very, very tightly connected oftentimes, and processes are very tightly coupled together. So you often see the need that they need to communicate a lot, even more than in like standard systems. And Binder is kind of a thing that facilitates that. I'll show examples of that, like kind of exactly how that works. But Binder is the way one Android app or one application communicate with another application. Intents are a feature that Android has, and intents are basically, they describe literally an intent to start something or do something in Android. So typically you create an intent. For example, you say, let's say I want to connect to this service, or I want to do this thing. Then I create an intent and I launch that intent. Yeah. Okay. So activities. Activities represent a thing that a user can do. So Android doesn't really have the standard programming paradigm if you have like a main function and that main function does something. Android instead has activities. So for example, right, so a really common thing on your phone might be that you click on, so for example, let's say like you click on like YouTube, for example, on Safari or whatever browser you use. Oftentimes, instead of actually going to the YouTube website, it'll instead jump directly to the YouTube app, right? That is basically kind of facilitated by this activities thing, where basically your browser will then launch an intent that tells YouTube to that it basically launches the YouTube activity. Another example, it's an activity basically just is basically a thing that it's an activity. So it's something that the user can do. They can be launched by other apps. Yeah, activities all must be noted in the manifest. They're launched via intents as well. We'll talk about like intent filters and stuff. Yeah, the top level activity for an app that this will launch whenever an app is launched is the main activity. That's the main intent. And each activity has a pretty complex life cycle for how it functions. There's like an on create function, on run function. There's all kinds of different stuff that that activity goes through in its lifetime. In fact, I might as well talk about that, because why not? Activity life cycle. There we go. So you can see it on the Android documentation here. There's a huge just list of things. It calls on create, on start, on resume, and then as an activity transitions from running to in the background, it calls various functions, and the activity gets an opportunity to do something using those callbacks. Yeah, so that's an activity. Services are very similar to activities in the sense that they also must be denoted in the manifest. An activity, a service is it's basically it is a service. So an Android app can launch a service, and other Android apps potentially communicate with that service via intents and parcels and basically via binder, and they can basically start talking with that system. There's different kinds of services. There's a few different services. There's stuff like bound services, unbound services. Yeah, I think that's pretty much all I have to say on the presentation side. But yeah, so okay, so in terms of the demo, basically what we did is there we go. So for the demos, I created this image. Technically, I didn't create it. Technically, Maddie Stone created it. So this Android hands-on image I created here. Maddie Stone, if you don't know, is someone who does or used to work at Google Project Zero. I don't know if she does work there anymore. And she is very smart, and she made a very good Android like reversing thing a long time ago. It still holds up very well. So yeah, if you ever want to walk through that, just look up Maddie Stone's Android reversing thing. And this is the image that she hands out. Yeah, and it's on the, if you want to start it up, because this is going to be used for the demos. It's called Android demo in the stack, and you can start this up there. The password is Android all lowercase. All right. So, okay. So when it comes to Android, there's a bunch of tooling we use when it comes to reverse engineering, just analyzing Android apps. One of the key tools that you end up using a lot is JADX. JADX is just a very nice GUI that decompiles all the Java code for you, and it shows you everything that's going on in the app. So we're just going to talk about a pretty simple app, the first app here. We're just going to kind of reverse it, talk about what's going on here, and yeah. So you open up JADX GUI just literally by running JADX GUI. The one we're going to go over is like Thai camera, which I don't know why it's called Thai camera, but I guess that's what we're working with here. All right. So the first thing we always start with generally when we're looking at an Android app is the manifest, because the manifest tells us all the things that are exposed from all the activities, all the services, all the key components that make up the Android app. So by looking at the manifest, you can get a very good idea of how it starts. In many ways, looking at the manifest, if you've ever done classic reverse engineering, it's kind of the same thing as looking for the main function, because it kind of just tells you where everything starts and how to work through the Android app. Because as you'll see, when it comes to Android, the code base can get very, very overwhelming very, very quickly. This is a pretty small example, but I'll think I can probably pull up another example later of something where it gets very, very overwhelming very quickly. And looking at the Android manifest will be very helpful here. So let's look at the Android manifest. So this is what an Android manifest is. First, we see the user permissions, right? These are the permissions that the Android, that this app is going to have to use. So for example, it needs to access the internet, needs to write to external storage, needs to have access to the camera, needs to be able to send SMSs, etc. read logs, stuff like that. We also see all the activities, right? The first activity that we see is right here. So this, in this case, is our application. Also, this is, by the way, the Android manifest is an XML. So you first see our activity here. Our main activity, we know it's our main activity because of this intent right here. So activities are launched by intents, and the way the activity is chosen is via this intent filter, right? So for example, let's say you launch the main activity, it's basically going to send this Android.intent.action.main intent, and that intent is going to it's basically going to look through the Android app and it's going to say, okay, let me look through my intent filters and let me see what what's the term? What activities or services can handle this intent. In this case, when we see the main intent, it's going to say, okay, we found an activity that can handle it. What activity is it? It's going to be com.cp.camera.loading. So we're going to go there because that we know that's going to be our main activity. So com.cp.camera.loading. We go here. So we start with our onCreate, right? Why our onCreate? Because we go to our activity lifecycle, because we know this is an activity. So we can start with our activity lifecycle here. We see that the first thing that is called when an activity is launched is the onCreate function. So it's reasonable to assume we can probably start with the onCreate function, right? So okay, this looks a little funny, right? So we already see some JSON shit here. We start a service, which is funny as well. Super.onCreate. So first thing we do, we register a receiver. A receiver is basically a what's the term? A receiver basically is a so I guess what is a receiver? Because what's the best way to describe it? Android. Yeah, it's a okay, yeah, that is a broadcast receiver. So basically a broadcast receiver. So in addition to receiving targeted intents, systems can also just broadcast intents to all apps when they want to basically have all apps view some kind of event. One of the way you handle this is via the broadcast receiver. A broadcast, so you basically extend the broadcast receiver class, and you basically, it's an abstract class, but, and you basically, where's the handling method? It's on receive. So you basically, whenever that intent is made to the system, it basically calls the on receive thing in every single thing that wants to receive that intent. So in this case, we have a broadcast receiver for the action start intent. And the class and receiver start activity receiver. Yeah. So, okay, so we start this service, this boot service. We call this login by post function, which is interesting. What's going on here? Is JetX like infinitely worse? Like what? Can't click on functions. Okay, login by post is here. So we make a URL, HTTP URL here, to this very, very not suspect IP address with a code. We make a post request specifically. I think should be a post request. I don't know if it's a post request. Yeah, it's a post request. And we get back the actual thing. But we get back the actual input, we parse it, and we return a string, it seems. Yes, we return a string. We then parse that JSON object. We get the content, the rule, the status, the IMEI. The IMEI content. Okay? So this does send SMS dot set text, ms show set text. Okay, so we got this button here. Okay. Okay, so it appears that basically what's going on here is we have this Firebase. I don't know why there's Firebase here, but that's a different question. We basically have this seems to be like kind of the key thing here. So in Android, you typically have resources and stuff on your view. So your view is basically your GUI, and your view has stuff like buttons, text, stuff like that. In this case, there's a SMS button, and the send SMS button. We're setting an on-click listener. Our on-click listener is this on-click function right here. How old is this? Oh wow, this is a very old version of JADX. This is free to support. But basically what this does, it seems, is it calls this send message thing here. I assume this send message is probably is right here. Yeah, so it calls a send message thing with mobile and content. So in this case, we basically create a bundle. We create intent to send an SMS. And then we create an SMS manager here. Is SMS manager an Android class, or is it a... Here's SMS manager. SMS manager is an Android class. So we create an SMS manager. We send intent, and we send a text message here. So basically, what we can reasonably deduce from this thing is that whenever we click this button, we send a particular defined text message. To what text message do we send specifically, though, is the funny thing. Loading.this.content. Where's content set? Oh, content is our IMEI. Huh. Interesting. Honestly, I'm not sure exactly how this will play out in runtime, but just kind of give you an idea of kind of like how an Android app works. I guess there's more stuff we can probably look into. We, for example, can see our broadcast receiver here, which is our M receiver. How does register receiver work? Receiver Android. So we call register receiver here. We call our broadcast, that's our broadcast receiver right there. So our M receiver is going to be, what is activity receiver? Where is activity receiver declared? I'm confused. Oh, activity receiver is right here. Okay. So whenever we receive an intent, an action start intent, we create an editor, shared preferences, video share, new handler post delayed, loading at the start activity. What is the action start intent now? So, I mean, I guess is this an intent? I guess action start might be one of their own custom intents, actually. Yeah. So, is there anything else I want to cover here? I mean, these are also broadcast receivers that are created. There's an intent filter here. So, for example, this broadcast receiver is going to be called whenever I guess com.android vending, by the way, is going to be Google Play. So whenever Google Play sends out this broadcast intent with install refer, presumably this receiver will then be called on every Android app that I guess supports it. I guess I don't know if I have anything else, because we have this action start. Action start is start activity. Okay, so whenever we start an activity, we run loading that start again. Okay, so I guess any questions on like kind of what that process was, like where we started, how we got to where we got? Yeah, any questions on that at all? All right, let me see if I can pull up like an actual. Let me see if I can pull up another app. See if I can. I probably have like 30 Android apps just sitting on my phone. So this is like an up-to-date version of Android. Do I still have Google? Oh, I don't have that project anymore. So have this, don't have that anymore. Don't have that anymore. And we're not going to look at. Fuck. It's like trolling. Yeah, I guess I don't really have anything here. I guess one thing I do have, I guess I could show here, is this one. This is actually a funny one. This was the APK that they handed out for the ShmooCon for Hack Fortress. This is a challenge at Hack Fortress. Really stupid one. Basically, single main activity here. You got the funny presidents. You got a button. Whenever you click the button, it you got set selection. I think you were supposed to have it land on, I think, Trump. I don't remember who. I forget about how you got the flag, but basically there was a decryption and encryption, and there was a spinner that it had, and there's a button. So whenever you click the button, it set the spinner to 0, and then it got your selected item. So basically, I believe it forced you to basically select Trump, because it always set the spinner selection to 0, no matter what. So basically, you had to basically either use Frida to stub this out somehow, or you had to, I guess, I forget, I think you had to like get the text for Biden, I think is what it was. Or you could basically, you would have to decrypt Biden by hand, or I guess statically. So basically the way you had to do this was, there was this. So it got the string, right? It got this string. So I guess the question is, where is this string? If you actually go to where it is, if you click on Biden, you end up with this number, right? Which is kind of funny. The reason you end up with this number is because Biden, and all these strings, for a matter of fact, these are actually resources, and these are resource IDs. If you want to get the resource ID, you need to go to resources, res, where would it be? Resources.arc, I guess here. Go to values, and then it's going to be in strings. So we see the actual string for Biden, Trump, and Jill Stein are going to be all of these. And these are all base 64, I believe. So that's kind of how you solve this challenge. It's a lot simpler. Not as much just, it was a pretty straightforward challenge because it was a very small binary. You're able to pretty much find the main activity instantaneously. Yeah. Any questions at all? I mean, that's kind of it. I mean, the demos mainly cover stuff like looking at functions, looking at what they do, as well as kind of reading the Android manifest is what the demos go over. All right. That's kind of all I have to say. Thanks for listening.